Two horizontal plates are placed 1.25 centimeter apart, the space between them being filled with oil of viscosity 14 pounds. Calculate the shear stress in oil if upper plate is moved with a velocity of 2.5 meter per second. So guys, first we have to understand the question, what is given in the question, and what we have to calculate in the question. So first of all, we have to understand horizontal. Horizontal means like this, and vertical means like this. Okay, so horizontal means just for the sake of understanding, I have given here parallel to the ground surface, and vertical is perpendicular to the ground surface, or actually perpendicular to anything. Actually, wall is also vertical, perpendicular to wall, and perpendicular parallel to wall. Okay, so just for the sake of understanding this numerical only, horizontal means parallel to, just assume that horizontal means parallel to ground surface, and vertical means perpendicular to ground surface. So two horizontal plates are placed between 1.25 centimeter apart. So these are the two plates, upper plate, okay, horizontal plates, and this is also a horizontal plate, okay, both. This is the upper plate and this is the downward plate, okay, and this top plate is a movable plate and this bottom plate is a fixed plate. Two plates are placed 1.25 centimeter apart, the space between them being filled with the oil of viscosity 14 pounds. Okay, this dotted black dotted, you will see here, oil is placed. Okay, oil is filled in between these two plates of viscosity 14 pounds. Okay, as we know the value of 1 poise is equal to 1 by 10 Newton second per meter square. Okay, here the value is 1 poise equal to 1 by 10 Newton second per meter square. So 14 poise will be 14 by 10 Newton second per meter square. So 1.4 Newton second per meter square we will get. So oil is filled between the two plates, okay, of 14 poises. Calculate the shear stress in oil if upper plate is moved with a velocity of 2.5 meter per second. So we have to calculate shear stress in oil, okay, shear stress in oil if upper plate is moved with a velocity of 2.5 meter per second. So this top plate is moving with a velocity of 2.5 meter per second. Okay, and this plate, so I have written here, it's a movable plate and it's a fixed plate. Okay, so in question we have to only find the shear stress in oil. Okay, shear stress in oil we have to find it. Okay, so these are the term 1.25, actually conversion of it's given in the centimeter. 1.25 centimeter, it's a distance, okay, between these two plates. The distance is 1.25 centimeter. So we have to convert the 1.25 centimeter to meter. So we can write like this. Okay, we have to divide by 100 for the conversion to meter. We can write 100 like this, 10 raised to 2. Okay, the 10 raised to 2, the it goes into the numerator, the sign will change and it will become in meter. Okay, 10 raised to 2 here is positive 2. When it goes up, it will become negative 2. So 1.25 into 10 raised to minus 2 meter. Okay, 1 point I have explained. Okay, and we have to find the only shear stress tau. So given distance between the plates dy equal to 1.25 into 10 raised to minus 2 meter. Okay, these are the distance between the two plates, 1.25. It's given in the centimeter, but we have converted it into the meter. So I have written here 1.25 into 10 raised to minus 2 meter. Viscosity mu, it's a 14 poise. So we know that 1 poise equal to 1 by 10 Newton second per meter square. So 14 poise, we have calculated here. 14 poise is how much? 14 by 10 Newton second per meter square. Okay, 1.4 Newton second per meter square it is. Velocity of upper plate u equal to 2.5 meter per second. Upper plate velocity. The plate is moving with a velocity of 2.5 meter per second. So everything should be in meter. Okay, everything given should be if in meter. If it is not in the meter, it is in mm or centimeter. So we have to convert it into the meter. Okay, So we have converted all the given values into the meter. Okay, now using the equation, okay, tau is equal to mu du by dy. So tau is equal to 1.4, which is value of mu, 1.4 Newton second per meter square. So 1.4 Newton second per meter square 2 by du. Okay, velocity of the upper plate 2.5 meter per second, 2.5 meter per second, and dy is the is the distance between the two plates. So 1.25 into 10 is to minus 2 meter. So by cancellation, second will get cancelled, meter will get cancelled. Here the remaining is Newton per meter. So Newton per meter 2.5 remains, okay, and 1.25 into 10 is to minus 2 meter. So 10 is to minus 2 will go up, okay, the sign will change, it will become 10 raised to 2, and 10 raised to 2 can be written down as 100. So 3.5 multiplied by 100, we will get 350 Newton per meter, okay, and divide by 1.25 remains here only. So after dividing 350 by 1.25 meter, 350 Newton per meter by 1.25 meter, we will get 280 Newton per meter square. So the shear stress in oil, we have got 280 Newton per meter square, okay. If any questions is there, so please ask in the comment section.